When you want to texture a 3D object, you are usually confronted with unwrapping. But what do you even need unwrapping for? Well, textures usually come as a two-dimensional image, and an image can contain many different things, and maybe you already have a vision in your head how the texture should look on your model. For example, you wouldn't want a tree bark texture to be aligned horizontally, so you have to tell your 3D software how you would like your textures to be applied. And you can do so by creating an UV map. For example, you could use this image of multiple colored squares and utilize the UV map to assign the different colors to different polygons on your model. And in case you're wondering what UV means, they just describe the axis of the 2D space your image is in. And to clarify that it isn't the same space as your 3D model is in, they didn't use X and Y as a name for the axis again. So an UV map is like a 2D version of your 3D model. But how do we make it 2D? Let's take a look at this bowl. You might think you could just smash it to the ground to flatten it and make it 2D, but if we texture our view and make the bowl 3D again, we can see that the inside is still untextured. Because even though it looked 2D, it still was 3-dimensional and half of the visible surface wasn't visible from the top. So in order to properly make it 2D, we have to cut our object. You can think of it like peeling an orange or skinning an animal or a plushie to make it less brutal. Both actions include flattening something 3D and both rely on being cut. I think the easiest example of the unwrapping of a 3D object you might already know is the unwrapping of a cube. And if you take a closer look, you might notice that even a cube needs to be cut in order to make it 2D. Because of the mentioned cuts, you will encounter what we call seams. Seams are the parts where the model was cut to be unwrapped, and the cut leads to the faces which originally been connected to be far separated from each other. So the 2D image might not be continued as expected there, and this might lead to undesired looks. You can see this when enabling the sync selection feature in the UV editor of Blender. This will sync the selection in the UV editor with the selection of the 3D viewport. Now, if we select the vertex where the seam is located, you can see there are multiple vertices selected in the UV editor. But how is this possible? Since the object is cut for the projection of the UV map, but isn't actually cut in the 3D space, there are more vertices in the UV map than on the 3D object. This isn't really creating a problem, but it can cause some confusion. There are multiple ways to cover the seams. For example, if you would have a big boulder with a visible seam, you could add bushes or tall grass in front of the seam. You can also try to move parts of the UV map trying to match the continuity of the texture. If you are creating a texture by painting it in a 3D software, your brush strokes won't be interrupted by the seam. This is because the 3D software will just project it through the correct places on the texture. To further demonstrate this, I've painted the whole monkey, and when looking at the texture, you can see that the paint is perfectly kept inside the bounds of the UV map. But this behavior can also help you when you're not painting a texture from scratch. For example, in Blender you can also use the blur brush and draw over the seams to blend both parts of the images together. This usually works better on textures that have a lot of variation or don't follow an easily recognizable pattern. And of course you can also set up your brush to paint with an image texture. For any texture you paint from scratch, you just have to add an image texture node to the shader and click on New. There you can set up the resolution and name of the texture and also the base color of the canvas. Switch to the Texture Paint tab, and on the right side you have your brush settings. Under the texture panel, click New, click on this icon and then open an existing image. Now back to the brush settings and set the color of your brush to white. And then you can start painting with the texture as a brush. You could also try to embrace the seam and try to mimic real life seams. Like for seams or metal textures, you could try to mimic welding seams, or for fabric, you could use stitches. A good UV map should have as few visible seams and visible stretching as possible. Stretching usually happens when faces on the UV map don't follow the proportions of their 3D equivalents. Also, the scale should be equally distributed. To check this, you can use the image texture node in Blender to create a UV grid texture and put it onto the model. Due to the UV grid image being consistent, you can easily spot stretching and scaling issues. Basically, if your model displays rectangles rather than squares, your UV map is stretched. In Blender's UV editor, you can also go to the overlays to display the stretching. In some cases, some stretching might look more natural than straightening everything to have zero stretching. We encounter what we call overlapping when multiple polygons of a model share the same space inside an UV map. This means that both faces will display the same part of the image. This leads to the problem that you can't add individual details, which are essential to professional texturing. Details include things like edge wear, rust, dirt, fingerprints, scratches, and more, places where they would usually be located in real life. This can also be used for subtle storytelling, as it can give info about the age of an object or the humidity of an environment. Also, if you're painting a texture from scratch, you of course also should get rid of overlapping. You might not face a problem with overlapping if you plan on only applying a set of tileable or seamless PBR texture sets. Sometimes you might even cleverly use overlapping, especially in game design, because it can help you to get more detail out of a smaller texture, which can help reducing VRAM utilization, as textures usually get loaded into the VRAM and bigger resolution textures of course end up in a bigger file size. There are multiple methods to create a UV map. In most tutorials, I see people just selecting all faces and using the Smart UV projection. This will cut your model based on the angle between faces. The advantage of a Smart UV projection is that your UV map won't have overlapping and stretching is usually also minimal. But depending on the model, there might be a lot of unnecessary seams being created. Like when trying it with the default Suzanne model of Blender, the result doesn't have a lot of continuity. You can guide the Smart UV project by adding some manual seams. You can do so by selecting the edges where you would cut the object and then open the edge menu and select Mark Seam. The same way you can also clear a seam. There is no perfect solution for where to put the seams. Usually you want them at places you won't look at or to be a bit hidden within the geometry. I chose the edges around both ears and around the monkey face. The Smart UV project will respect your seams but still create seams on its own based on the angle. You can customize the angle further to see if you get a good result from it. If you want the unwrapping to solely be based on your seams, you can use one of those 3 unwrapping options in Blender. Just play around with the different methods for a bit and choose the option that gives the most pleasing looking result. You can then further optimize your map in the UV editor by scaling different areas of the map or using the relax and pinch options. If you just want to get the job done quickly, you can also use some automated solutions. I like the pack islands operation. Islands are the different isolated areas of an UV map, and this operation will get rid of overlapping and try to scale them to the bounds of the image to get the most out of your image resolution. Since many objects just consist out of multiple simple objects, you can also combine multiple simple projection methods for different parts of your model. For example, cube projection, cylinder projection, and sphere projection. Cube projection will project the mesh over the 6 faces of a cube. This will usually end up in straight but overlapping UVs, so you might have to clean them up afterwards. Sphere and cylinder projection might give similar looking results. The main difference is that the cylinder only has a curved surface around its z-axis, while the sphere projection is curved along all axes. Just be aware that cylinder and sphere projection are relative to your view, so you might want to go into the top or front orthographic view to get the best results. You can then in the end get rid of overlapping and make them all fit into the space. You don't need to select your whole model and get a single unwrapping method to work. You can just combine multiple methods and then combine all of the results to fit into the bounds. You can also create multiple UV maps for one object, because maybe the eyes of a character model need to be very detailed. So you want to use a separate map for the eyes, so you can make use of a full high-resolution image rather than just assigning the eyes to a small part of an image. To use your UV map, you just have to use an image texture node in Blender's shader editor. It will by default use your UV map. If you want to further edit the mapping in the shader editor, you would have to use a mapping node. But the mapping node won't default to your UV map, so you will have to use a texture coordinate node and connect the UV output to the mapping node. When you want to scale your texture, please always use the mapping node. don't get used to doing it by scaling the UV map in the UV editor, because when your UV map is out of bounds, you will probably run into trouble when exporting it to other softwares. If you want to use multiple UV maps in the shading editor, you can add the UV map node, where you can choose one of your available UV maps. So you would need one node for each map you want to use in this material. It also works when only having one UV map. But people usually just use the UV output of the texture coordinate node because it has more mapping options you can cycle through. Those mappings are mainly useful for procedural textures or simple models. You don't always need a perfectly optimized UV map, especially if you aren't going for game design. And there is no magic bullet for UV maps. You just have to get a result that you think looks good and doesn't hinder you in your further process. So as long as it works, looks good, and you're satisfied with the UV map, it is a good UV map. I hope I could make UV unwrapping seem less scary to you and provide answers to some things you were wondering about and help you connect the dots. If you like this format, let me know by subscribing to the channel.